Yeah, I will start now then. So basically, this will be a brief description of what we are doing. Aaron and I, we are doing for the research for metacognition, and in particular at OICB, but also in relationship with collaboration that we're doing with Harvard and the North Anglia Education with the Delta Project. So my name is Dr. Fabrizio Brienza. I'm second in department in mathematics and teacher in mathematics, and Mr. Aaron Eckhoff is the head of maths. So the first thing actually that I would like to talk about is what is metacognition. Now, of course, but as you may already know, metacognition is, in an easy way, is thinking about thinking, which is absolutely fine, is a good description. So think about how do we think, which is not something easy in general, but is much more than that. It would involve a lot of things. And it's not just students, of course, it's everyone. Everyone is affected by that. But particularly, of course, we are going to do our research for students because we are teachers that were interested in how students will learn. But so what is metacognition? It's more like thinking about how we can plan, monitor, evaluate, make changes on our own learning behaviors. So understand how can we deal with challenges as well. Be more efficient when we deal with challenges. Are we self-aware of our cognitive thoughts, so or the cognitive process in general? Can we self-regulate the process? It's not an easy task at all. So as you can see, it would involve a lot of different aspects. So that's why you can see in the first slide the Project Zero and the Delta Project. So what is about? The Delta Project is actually the collaborative effort made by the North Anglia Education in collaboration with Harvard. And the Project Zero is made by the research team at Harvard. It was launched in 1967, so it's quite an old project. But actually, what we are doing now is to use this. It was born, actually, it was launched in particular for arts, not other subjects, and for primary schools, but slowly actually changed and moved into different contexts and different disciplines as well. So what happened now is that we can use this research framework made by Harvard for different types of subjects, and in particular, Aaron and I, we are using that now for the first time for year 12 and year 13 classes. So a little bit older students, if you wish, when the mindset is actually set in a way. It's not like working with primary school students, but it's absolutely useful, and still we have a lot of interesting things to share. So we start in September 2024, we will finish in August 2025. So it's a one-year research for now. And what we do, we just follow different seminars, and we try to talk about our research, to collaborate with other teachers as well. So we are in a group, for example, with 2 teachers in Hungary, another teacher is in Switzerland, and they teach really different subjects like geography, English, art as well. We are teaching maths, of course, so we can actually have a chat and understand how the different approaches can be used in different contexts. It's absolutely amazing. So what is the Harvard Project? The Harvard Project is actually the framework, the theoretical framework. So what is that? It would provide us with the thinking routine. So what is a thinking routine? It's basically a recipe, so a step-by-step prompts that we can use in our classroom to help students with some, what they are called disposition, critical disposition. So it would be crucial disposition. So it would be critical thinking, creativity, curiosity, compassion, commitment, collaboration, as you can see from the slide. But it's much more than that, of course. But we focus on these attributes, which sometimes are a bit difficult to assess in a classroom. But with this framework, actually, we found it that we could reflect on possibly things that we already do in a classroom, but that sometimes we really didn't understand the power, or we could actually change them in a much better way. So the idea is to follow some seminars on these thinking routines and then reflect in a journal. So we can share our research and see other researches. And we found it that really, really useful. But what is in practice? But in practice, it basically supports students with reasoning at higher level. And what we would like to do is to what is called making thinking visible. But what does it mean, making thinking visible in a classroom? First of all, is to organize our thoughts. But sometimes we are thinking about stuff, but we don't really organize that thinking in a good structure. So teachers can support students in doing that. Again, it's not an easy task. It's something that would require a lot of time, but it's definitely useful, and we see after in a moment why. But also normalize the fact that we have to think. So we are not expecting just students to give us an answer to solve a problem. I know in the end they have to do an exam, but at the same time, it's extremely important that we focus on the learning process to better understand the subject, but also how our brain works. So encourage high-level thinking, but also go deeper in the content learning. And also help students to be more self-aware of their own cognitive processes, which is something that, again, is not an easy task, but it's something that is extremely important because it can allow us to adjust and improve and be better, hopefully, in the final exams. It's something that we, in a way, we already do in a classroom. So in particular, how can we make think visible? So for me, the three things that are important are questioning, listening, and documenting. Of course, there is much more than that, but I think these are the crucial attributes. So in a classroom, actually, we should questioning a lot of students. So either follow-up questions to help understanding or clarify thinking for students, but also I think in mathematics in particular is important probing questioning. So questioning that would allow students to go deeper, to reason, and to pinpoint, for example, misconceptions. They're extremely important, but at the same time, we need to listen. And this is something that is not easy for teachers sometimes. So stop, pause, give students the space to articulate their own thought processes, which is something that it's extremely important because students need to feel like in a safe space when they can talk, that they can discuss, and they have time to do that. So they don't are under pressure. And the last thing is documenting. So why documenting is important? Because again, it's a learning process. It's not something that you do in one specific lesson, but it's more of a process. So documenting the process is important. And that's why we do the reflective journal. So this is roughly the main idea. Now we move to what is actually the thinking routine that we've used, Aaron and I, for our research. So the first thing is the critical thinking. So for the critical thinking, we've used what is called the routine, which is called the think that, stand back, and push backs. So what is this routine? Basically, in a way, it's something that we've already used, in particular in the mathematical environment. So what we do, we want to solve a particular problem. So I have used this thinking routine for a year 12 class when we were dealing with mathematical proofs. Dealing with mathematical proofs, again, is not an easy task, also for good students, because we're used to use the proof as it is. So we're not proving it. We are using the statement as it is. So how can we prove a statement? So we start with an hypothesis, and given the hypothesis, we want to prove the thesis, which is something logical, something easy, but sometimes is not. And for good students as well, what they did is what is called the circular reasoning. So they've tried to prove the thesis by using the thesis, which is something that you really don't understand sometimes that you're doing that. So that's why I think using this routine is useful. So there are 3 steps. Now, I didn't use the exact words, but I at the beginning told them to think about what would be the first thoughts that you could think for solving a particular statement. So I've started with easy statements at the beginning. And then after that, maybe you can do a bit of a pair work, so work in pairs, to assess each other's reasoning. So what will be the weaknesses, what will be the positives, and what can we do now? This is the stand back. So critically assess what we thought at the beginning. And then after that, the pushback part would be, what can we do now to, after we challenge that, how to improve? And this is something that it looks easy, it looks something that we should do actually, but it's something that is important that we reflect upon, because sometimes we don't. And in particular for mathematical proofs, I thought it was a good, I was actually teaching mathematical proofs, so I thought it was actually the good routine that we could use for this one. And in fact, I have to say I got positives. So students were more confident in a way to tackle proofs, particularly avoiding circular reasoning, which is the most common misconception. The downside is, of course, that it depends a lot on the teacher expertise. So you need to be, in a way, quite short of the proofs that you are doing in lesson. But at the same time, the time constraint a bit is another downside. But I think you can embed this in a lesson every day. To be fair, it's not something that you have to do only one lesson. You can do at the start of a lesson just to pose students to understand what they're doing. So, of course, the main point is to challenge misconceptions, but at the same time, it would be for teachers to support students, so do a bit of scaffolding, so support students in a classroom if they feel that there are any other obstacles to the actual thinking process. So, for example, some students struggle a bit with algebra. But for me, it was not the main content in this case. So the main focus is the thinking to solve the statement, to solve the proof of the statement. So what I would like to do is to support students to avoid to move their focus into something that is important. Because of course we are human beings, so we try to reduce our effort, so reduce our energy, which is absolutely fine. It's what I do as well. Is a normal thing. But what we need to do as teachers is to support them to shift their focus maybe sometimes and try to improve their improve their effort in a way, so tend not to reduce their energy, particularly when we're dealing with mathematical proofs. So the other two routines that I found useful would be M&Ms, and that was then, this is now. So basically the M&Ms is messenger, message, sure. So what does it mean? We didn't really use in the mathematics, but I think it would be useful, for example, for students that they're doing a research like EPQ. So in that case, you can assess the messenger and the message and see if they're reliable, and we can trust the messenger. This is something that is useful in research, and we would like to use a lot more in the research. But I think Aaron used that was then, this is now. In particular, he did it in when they finished a particular chapter. So basically, the idea is to try to reasoning on what we knew before that particular set of lessons and what we know now after we've done the lessons. So this is important because sometimes we finish a chapter and we don't find that time, or students in general, they don't think it's important to find that time to reflect and think about what now we know, because it is also a good way to understand what we need to do after. So this is roughly what we did with the critical thinking. For the creativity, also, I think it was quite interesting. So the creativity routine is called the what if instead. So the idea is to support and assess creativity in students, which is is not easy. But with this what if instead, the idea is to explore a topic, ask a question, and then ask what if instead we would like to do in a different way. And this way of reasoning is useful, particularly when we are exploring a topic for the first time. So I think Aaron used this routine when students were working with intersections between planes and lines in 3 dimensions. So we have a lot of different situations. He started with the easy situation when he had like 2 straight lines that would intersect. And then they tried to solve that problem. And then after that, he tried to prompt them to say, what if instead of having 2 straight lines, we have 1 line and 1 plane? What if we have 2 planes? What if we are in more than 3 dimensions? So this is kind of generating a train of thoughts. And it is absolutely important for students to be creative and hopefully generate their own questions. What I found also useful for myself when I did the research is to use that, as you can see from the slide, for a year 13 class. So it was a further maths group and we were doing polar curves. So the polar curves are curves that would be similar to the shapes that you can see in the slide. So in particular, I looked at curves with the equation r equals cos n theta and r equals sine n theta. So r is a radius, n is a natural number, cos and sine will be the trigonometric function, theta is an angle. So what I've done, I've just gave them these polar curves. We did a bit of some examples, some easy examples. So what I did at the beginning was just a discussion on what can we do to analyze these curves. Again, this is an open-ended problem because it's not giving you just one answer. I don't want just one answer. And I thought it was good because it would discourage them to just give me one answer. So their mindset doesn't have to be, I have I want that answer. So it's more, I want to focus on the thinking process. I want to focus on what can we ask ourselves to solve this problem. So that's why creativity here is important. So what I did, I started with simple questions and I prompt them. So I think the first thing that they did actually is assume n equals 1, which is absolutely fine. It's the first thing that we do. We try to reduce the effort, we try to reduce the energy and do the simple cases. And in fact, this is what happened. But it started with that one. And when n is equal to 1, we have the black shape, which is the circle, which is something that we already did in class. But then I asked them, what can we ask then? What can we do? What if instead n is not 1? For example, this is an easy question, actually, but it's the first step in a way. So what we are doing is, okay, when n is equal to 2, we have what you can see the orange curve, which is the infinite shape. And then when n is equal to 3, we have the 3 loops. When n is equal to 4, we have the green. When n is equal to 5, we have the purple one, and so on. So they can also use, of course, softwares. Desmos Series 1 is graphical software that is good, which is absolutely fine because it's an exploration, so it's good. And then the next step would be, what if instead we would like to find a pattern between the value of n that we found and the curves that we got? And actually, this is a different step because it's not just asking different values of n, it's asking a pattern. So it's another level, a higher thinking level. And the what if instead routine would allow us to move from one level to another. So this is a different thing from the original routine. So that's why I recalled this one a what if instead cyclic version. So I created this new routine and I found it really useful, particularly when we are in open-ended problems, to support students with moving from one step to the other. So what happened basically is that after that, actually, of course, you can see that the number of loops would be actually the number n, which is something that you can easily see. But also they found that when they were using a software, r could be negative. So they asked me, what if r is negative? It's something that I didn't even think about. And some students asked me, what if n is not a natural number? That was absolutely brilliant. And n can be a rational number, n can be an irrational number. So there could be any types of numbers. And we found that when it's irrational number, the curve will not close. So again, another layer that you can add to that one. And then there's no end to this. So it's an open-ended problem. So you can keep going like this and continue to boost creativity in students. Now, of course, this would encourage to explore different ways to tackle a problem and looking at different perspectives. So the two main attributes would be fluency and flexibility. So the fluency would be how many methods do we know to explore a particular topic? Or the flexibility also is important. Are we able to move from one method to the other? And this is not an easy task. And I think these open-ended problems with the what if instead cyclic routine is definitely useful to boost fluency and flexibility in students. So understanding more methods and how can we move from one method to another. Of course, there are downsides, unfortunately. The time constraint is a huge one because open-ended problems require a lot of time. And sometimes we don't have a lot of time because we have to finish the content. So we need to actually create the time to do so. So maybe using, I don't know, other options, but also we can use this what if instead for problems that they are not open-ended. And I think Aaron used that for solving system of equations, asking, for example, the what if instead we have a different types of system, what if instead we can change the parameters. So you can actually use that in a day-to-day lesson, to be fair. It doesn't have to be on open-ended questions. But for me, I thought it was interesting to embed these with open-ended tasks. The last routine that we've done, I think it was the most recent, is the curiosity routine. Now, the curiosity is a hard trait to assess in students because the idea is to understand how curious is a student is more like to understand how the student will tackle a problem, particularly when we start looking it for the first time. So in this case, Aaron supported them with, so that the two thinking routines were know, not know, want to know is the first one. And the second one is the curiosity dig. So the know, not know, want to know is basically what we do at the beginning. So what do we already know about a topic and what we don't know, and what we would like to know about that topic. So now that we know what we know and we know what we don't know, what can we do after that? And the curiosity dig is a bit different. It's more like asking some questions on a particular topic to improve our understanding. And after that, set another set of questions to support us with answering the previous set of questions. So these techniques, they're something that we, in a way, possibly, not everyone, but definitely the vast majority of us would use when we approach a particular topic. So I think it's important to let students know that these kind of strategies are useful if they are stuck. So sometimes we don't know what to do with a new topic. So this is good. We can, and I think Aaron used it quite wisely. He used it, for example, at the beginning of when he's introducing a new topic in classroom as a discussion. It's absolutely fine. And I think the key thing here is collaboration with students, because if the problem is sometimes we don't know what we already know, and we don't know what we don't know. So it's a tricky thing. So it's good to kind of write some stuff and then talk about with your classmate, for example, to check actually what we really know about topic and what we would like to know, because we're not sure. And also he used it for revision, because I think when we ask ourselves what we know and what we don't know and what we would like to know, then we can use those questions to set our revision. And is really useful in that context. For myself, I've used that for supporting a year 13 student who is preparing for the Cambridge STEP. It's quite a hard mathematical exam to enter Cambridge. So he got an offer, but he needs to do these exams. So what it is, the exam is based on 3 subjects: pure maths, mechanics, and statistics. He's a really good student, I have to say. He's curious enough. But the problem was, so in pure mathematics and mechanics, he doesn't have a lot of problems. The statistics, particularly, he was struggling because he didn't do some topics at all. So I thought it was good to kind of, in a way, embed this use of these routines. So I started with the know, not know, want to know. So I tried to have a chat with him. I was helping him during super curriculum time. So we had this meeting and we started saying, okay, what do we already know about statistics? And he told me, okay, I know this, this, and this. That is good. That is a good start point. What we don't know that we need to work out. And that was the other stuff that he was in further maths that he was not able to do. That was good because he had a clear mindset in that way. But of course, I supported him with that. But it was a good start point. So after that, we try to ask questions. So the question for me was more kind of try to link what we already knew with what we would like to know. So for example, there is the Gaussian integral and the Poisson distribution that are quite high level concepts. They can be actually linked to context, to topics in the previous content. So for example, the binomial distribution, that is an easier one. Or what is a distribution in general? What is the purpose of having a distribution? So these sorts of questions would support you then to better understand. Also, the connection between discrete and continuous distribution as well was supportive to him. And then I've used also the curiosity dig, because he is really curious. So I thought it was good to, let's think about more in depth. So what other question can support us with answering the previous questions? And for example, are there any real world application, for example, with Gaussian normal distribution that could support us with that? So why normal distribution is so important in real life? And he really appreciated that because again, he's a really good student. So actually after 2 weeks, he told me, actually, I'm feeling confident now with statistics. And of course, I mean, it was quite, in a way, easy because he's a really good student. But I think that this understanding of the right questions that we need to ask is absolutely important, and definitely supported him with that. So just to conclude now, what I want to say is, so this is roughly what would be the thinking routine and how did we use that. Okay, it's not finished here. Of course, we continue to use this routine. We also had some meetings in the OICB with other departments to actually prompt other teachers to use this thinking routine, because it's not just mathematics. It's more like how do we use the thinking routine in a classroom, independently on if we are in a math classroom or in an English classroom with year 13 students or with year 9 students. So the thing is that it's important to be intentional. So it's important to understand that when we use a thinking routine, we have to use it not just creating a fake scenario, but creating a thinking routine or using a thinking routine because we need to tackle a particular problem. So for me, for example, was the mathematical proofs or open-ended problems or other stuff. But or for Aaron was like how to support students with revision. So every question actually can be tackled by using a thinking routine. So it should not be the other way around. And implementing the thinking routine, it doesn't mean that you do in one lesson and the thinking routine, it didn't go well, then it's not good. That is not the good attitude. The attitude should be use again and again, maybe the same thinking routine for 1 month, after we actually see and adjust and see what we can do. And also we don't want to overwhelm students, really. We want to use the routine day by day, step by step. And it's absolutely crucial for me, that one. And also we have to be aware that we have different classes. So I applied the thinking routine, and Aaron as well, with year 12, year 13, some year 10 groups as well. But maybe other teachers would like to apply the thinking routine to year 9's classroom. And also the thinking routine should be applied in a different way because it should take into account of the different developmental stages. And also we can apply the routine in a lot of different ways. You don't have to apply the routine as it is, but you can, in a way, change the routine and adapt the routine to different classrooms and in a different way. And sometimes, because we are in an international college, it's also important to apply the routine taking into account of the language barrier. So we need to possibly rephrase sometimes. We don't use pushback, for example, because is useless for some students. So it's something more, let them understand really what we are talking about. And again, keep in mind that shifting our cognitive reasoning is not easy. So it means that when we want to shift our mindset, it takes time. And also for me, I mean, I have a specific mindset now that I'm older. So I'm aware that it's really hard to change my mindset. So we need to insist. We need to insist and use the routine for a longer time, possibly an academic year even, depending on what we would like to achieve. Collaborating is extremely important as well. As you could have seen, students have to collaborate between each other, but also teachers have to collaborate with students and with other teachers. So that's why we reflect and we are in groups with other teachers. It's absolutely paramount for me. And of course, the teacher expertise is important, but not only the subject expertise, of course, that is important, but also the metacognition research, the cognitive approach, these sorts of things teachers should know. Otherwise, we cannot use the thinking routine properly or taking into account of the research that is behind. And under the line, this is an experimentation. It's not a right or wrong. So if you use a routine and it's not going well, it doesn't mean that it's wrong. It just means that maybe it was not a fit for the problem that you were thinking of or for the class that you were thinking of, or maybe you have to use that for a longer time. So you need to avoid to think, oh, that was wrong, is not good. That is not a good attitude. And the last thing, as I said, is the documentation. So because is a process, is a learning process, is not using the routine only in that particular lesson for that particular time. We need to document. So we need to understand what's going on. So in 1 month, 2 months, 3 months, what happened? So we need to write, or we have OneNote when you can actually record all the stuff the students did. That is extremely useful because without that documentation, there's no possibility to improve, no possibility to change our thinking routine and our approach in a classroom. Yeah, thank you. This is pretty much what I wanted to say, actually. I'm going to end the slide. So if there are any questions, I will take them.